Okay, today we're doing parametric relations and inverses. You'll learn about relations parametrically. Ooh, that's what a parametric relation is. And inverse relations and inverse functions. Why? Because some functions in graph can best be defined parametrically. Very seldom do we use that, but you're getting exposed to it. So in case you have to look at it in college, you'll see it once. While some others can be best understood by inverses. Okay, another way to define functions is to define both elements of an ordered pair in terms of each other using a variable t called a parameter. Okay, so you have x equals t minus 1, y equals t plus 2. So x would equal, at negative 3, it would equal negative 3 minus 1, which is negative 4. Y at negative 3 would be negative 3 squared plus 2, which is 9 plus 2, or 11. So at negative 3, the parameter of negative 3, you'd have the ordered pair negative 4, 11. At the parameter of 0, you'd have the ordered pair of negative 1, 2. At 2, 2 minus 1 is 1. 2 squared is 4 plus 2 is 6, and so on. Okay, whoops. So it'd be the ordered pair 1, 6. Okay, so parametric equations. You'll be given a t, you plug it in for x, you plug it in for y, you get an ordered pair. Okay, so they did them for all the points. You just plug them in and solve. Easy peasy lemon squeezy. In this class, parametric equations are very easy. We keep them very basic. What's the algebraic relation between x and y? Called eliminating the parameter. To eliminate the parameter, what we do is we set y equal to the t and then replace the t with what t is equal to and solve. So here we can see y is a function of x. Because remember, y was equal to t squared plus 2, and x was equal to t minus 1, right? So if we got t alone, we added 1 to each side. So x plus 1 equals t. So we took the x plus 1, plug it in for the t, and solved. Okay. An inverse relation is when you switch the ordered pair, the numbers in the ordered pair, around. Okay. An inverse relation. To see if an inverse relation is a function, it'd have to pass the horizontal line test. Just like to figure out if a relation is a function, that passes a vertical line test. For an inverse, it has to pass the horizontal line test. So inverses, we write with a negative 1 on the top. Okay? So an inverse will be written that way. So find the equation that's the inverse of this function. So our function is f of x equals 2x over x minus 1. What we do is rewrite it with a y there. Okay, this is our function. Then we're going to flip-flop the x's and the y's. So we're going to rewrite it as x equals 2y over y minus 1. And we're going to get y alone. And when I get y alone, that will be the inverse of the function. How do I get y alone? Well, this one is a little bit more difficult than your average equation. You have to multiply both sides by y minus 1. So then x times y minus 1 equals 2y. Now we got to get the y's together somehow, so I'm going to distribute xy minus x equals 2y. Then I'm going to move the 2y to one side, the x to the other. So xy minus 2y equals x. I added x to each side and subtracted 2y from each side. Now I want to get y all by itself on the left side. What magic mathematical jargon will I use to figure out how to get y all alone? I'm going to have to do what to it? The left side. It's like dividing using an F factor. We're going to factor out the y. So then y can be all alone. So then we rewrite it as f inverse of x equals x over x minus 2. This is the inverse function of this function. That is the inverse function of that function. Okay? And they went through the steps there. Now, the reflection. If you draw a line at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, like this, an inverse function will be reflected around it. This point here will go to this point. This point here will go to this point. The point at, let's say we have 2, 5 as a point. Then its inverse will be at 5, 2. This point will be out here at this point. So it'll kind of come like this. It'll get really close there. And it'll go like that. See how if we take the mirror image across this line, this equals this. If we look at the points, this is a point 0, 1. This is a point -1, 0. On the mirror image side, this is a point 0, -1, which is a mirror image of this. This is a point 1, 0, which is a mirror image of this. 2, 5 goes to 5, 2. See how we're just switching the orders of the ordered pairs to get its mirror image? Switch the order of the ordered pairs, you get a mirror image. Okay? All right. We'll talk about the rest of this card on Thursday. But what we're going to look at is some of the problems that you'll see today. Parametric equations is where we start. Easy peasy lemon squeezy. What do we do with the 2 in a parametric equation? Put it in for each t. So what's 3 times 2? 6. What's 2 squared plus 6? 10. Okay? Just put in the 3 for each of them and solve. You get an ordered pair. Okay? And on this one, you put in -3 to get -12. Put in -3 to get -10. Put in -2 to get -8. Put in -2 to get -7. And then we get, I bet, -4 and -4 and 0 and -1 and so on. Okay? What's the algebraic relationship between these two? Okay? Well, what's happening as x increases or increases by 4, y is increasing by 3. Okay? As x increases by 4, y is increasing by 3. And when x is 0, y is negative 1. So the relationship between them, my slope would be the change in y, which is up by 3, over the change in x, up by 4. And when x is 0, y is negative 1. That means my y-intercept is at negative 1. So it'd be the equation y equals 3/4 x minus 1. Does it determine y as a function of x? It sure does. Now what I could do up here, if I wanted to, if I wanted to figure this out a different way, I could say, well, t equals 1/4 x. If I divided both sides by 4 and plug 1/4 x in for t. So y equals 3 times 1/4 x minus 1. So y equals 3/4 x minus t. Could do it that way too. Either way we could do it. 3/4 x with a y-intercept of negative 1 would be graph C. Okay, inverse function. Is this relation a normal function? A normal function. Does it pass the vertical line test? No, it does not pass the vertical line test, so no. A vertical line intersects the graph at more than one point, so the relation is not a function. Does the relation have an inverse that's a function? Does it pass the horizontal line test? Yes, it sure does. Since it passes the horizontal line test, yes. It does have an inverse that's a relation. All right. Does this relation here pass the horizontal line, vertical line test? This one.
Yep.
Yep. Does it pass the horizontal line test?
Yep.
Yep. So it's yes for both. Is this function 1-to-1? So this function looks like 2x minus 5. So it looks like that. Looks more like that. 2x minus 5. Okay. Does it, the function is 1/1, find its inverse and domain. So what's the inverse of this? To find the inverse, this is y equals, excuse me, 2x minus 5. How do I find the inverse? You switch around the x and y. So x equals 2y minus 5 and solve for y. So add 5 and divide by 2. So y equals x plus 5 over 2. That is the formula for the inverse function, x plus 5 over 2. It would look something like x plus 5 over 2, which is 1/2 x plus 2.5. So 2.5 might be there, slope of 1/2. What's the domain of this blue line? All real numbers. Very good. Okay. And so inverse functions, you have a couple more. So I'll let you see if you can figure those last couple out on your own. So I will post this assignment. You'll have 20 minutes to work on it. You should be fine to get it done in about 20 minutes. There's 8 questions is all. Now, Kennedy, if you'd like to go to El Baño, you may.